Welcome student to part 2 of the substitution method. In this video we will learn how to use the substitution method in more complicated integrals. As we said last time, the first thing when we look at an integral and we see an inner function, in this case is this one. Why we consider this as an inner function? Because it's inside the square root. We have to use the substitution method. Now, in order to use the substitution method, we have to choose something to be u, and we said we need two important things in choosing the u. The u must be an inner function, and the derivative of u is almost somewhere in the integral. So if we go ahead and we apply the same concept here in this example, okay, what I will choose my u to be 1 minus x cubed. Now, how can I make sure that this substitution will work before I do all the steps? As to see what is the derivative of u, it is 3x squared. Now, forget about the 3 because we don't care now about the numbers. Look at the x squared. Do you see it somewhere in the integral? If the answer is yes, proceed. We proceed with the same idea. If the answer is no, there might be a better u to be chosen. Now, in this case, because the derivative of this is a 3x squared, don't look at the number, just look at the x's. X squared is in the integral, so I think this will work fine. Next step, we need to find the du. And the du is 3x squared dx. This means we just need to find dx by itself, because this is where I would substitute. This means dx is just du divided by 3x squared. Now we take those two pieces of information and we substitute them in the original integral. So the integral is x squared square root of 1 minus x cubed dx. Now let's see what do we have. Now inside the square root I will call it u, because 1 minus x cubed is u. Now, x squared on the top, I don't know, I would just keep it as x squared on the top. And then, instead of having dx, I will write du over 3x squared. This will lead me to cancellation of x squared and x squared. The 3, because it's constant, will go outside the integral. So we'll just do this, and the next step, it will be 1 over 3 integral of 1 over square root of u du. 1 over square root of u du is just, we have to rewrite it as u to the power of negative 1 over 2 du, and now this is a fairly easy integral. We just need to add 1 to the power and we divide by the new power. So if we add 1 to the u, it will be u to the power of 1 over 2. If we divide by 1 over 2, this will give me 2 plus the constant of integration. Now this is just the final answer will be, we substitute back u to its original function, and that will be 1 minus x cubed to the power of half plus the constancy. And that should be the final solution. So here we just follow the same major idea of having a good substitution, and then we just follow the steps to translate this integral into an easy one here. Look at this one. That's the elementary integral. That's how we know from calculus 1 how to proceed with it. Let me go to the next question, which is this one. Of course, if you look at this integral, this is not one of the list, so we have to use the substitution. So we have to look at inner function with the derivative almost in the integral. Now, I can see here as ln x is the inner function. It's inside the square. So this could be a good choice for my u. Now, how can I at least make sure that this will work fine here in this example? Is by finding the derivative. So I will just take u to be ln x. Now ask yourself, what is derivative of ln x? It is 1 over x. Do we see 1 over x in the integral? Yes, we see it, because this is 1 in the top, we don't write it, and this is over x. So our substitution seems to be a good one because the derivative is there in the integral. So we have to proceed with the same steps. We find du. But what I really want to find is dx. So what I need to find is only dx in one side. So you will take 1 over x and you will take it to the other side. It will be just x du. And now I will take those two information here and I will substitute them in the integral itself. Ln x is just u. Dx, it is just x du. I think we can see now there is a cancellation, x with x. So what will be left out is integral of u squared du, and that's a very straightforward integral. We just need to add 1. So it would be u power 3 plus the constant, and we divide by 3. And the last step, we have to return back from u to x. So we have to substitute u into its origin, which is ln x. And that's how we solve this question. So once we get u and du on the track, then the rest of it is just mechanical. We can go through it easily by substitution, cancellation, and integration. Let me go to question number 4, and this is a very important question because you need to memorize the results. So let me just go ahead and try equal something. I will write the final answer here so that you need to memorize it because you don't need to do the steps every time. You have seen it once, practice it twice, and then you can use it whenever you see integral of tan, and we will see integral of tan through calculus 2 so many times. So just keep it in your mind and we will see how we can do the step. Now, if you look at this question, the first thing that comes to your mind is, we don't have an inner function. Why do we need to use the substitution? Now, the idea is take tan and write it. What is tan? Tan is sine over cosine. Okay, so still I'm not sure which one I will use the substitution here. If you are not sure, let me do something. We don't need to do it, but just to make sure you know why and which one we will be using. Now, cosine in the denominator, if you take it up, what do we get? We get cosine x to the negative 1. Now, do you see where is the inner function? Now I can really feel that this one is an inner function. It is inside a bracket to the power of negative 1. So this seems to be a good choice for you. And that's exactly what we are going to use. So I will use this one here, the cosine, to be my u. And I will check if this is a good choice or not. So u equal cosine x. Now how to make sure that if this is u, we have a good choice. We take the derivative of cosine, which is minus sine x. Forget about the minus. Do we have sine x somewhere in the integral? Yes, we have it there. So we need to proceed. So just a matter of having the colors here. Cosine x, if we do the derivative, this is minus sine x dx, and then the left side we have du. Now remember, I don't need du. What I really need, and what I'm looking forward, is just dx, and that will be minus sine x and du on the top. So let's go back to our question as we just did it. Integral of tan x dx equal integral of sine x over cosine x dx. And now the cosine, I already called it u. The sine at the top, I keep it as it is. Now dx is minus sine x in the denominator, and then the top we have du, and off we go with cancellation. So we cancel sine x with sine x. Take the negative outside. And then we have 1 over u du, and this is fairly straightforward integral here, minus ln absolute value of u plus c. So the final answer is negative ln absolute value of cosine x plus c. Now that's the answer that you need to keep it in your mind once for all. With the negative. And that's exactly what I'm going to write here on the top, is this is negative ln absolute value of cosine x plus c. So please keep this in your mind, that this is the integral of tan x. Okay. Next one is this one here, and let's see how we can do this one. Again, here this integral seems to be complicated, so we need to use the idea of substitution. So we have to look at the inner function, and I think the inner function is clear because it's already inside the bracket of power of 7. So I will go ahead and say that this is my inner function. Now, how can I check if my answer is correct? As usual, we take the derivative. On a side, take the derivative is 2x. As we said, we forget about the 2. What we left with is x. Now look at the integral. Do you see an x? Now you wonder, you have seen x power 3 and you don't see x. That's fine, because I'm telling you, do you see x? You need only one x. Here you have 3 of the x's. That's fine, you have more than what you need. It's okay, but do you need x? Yes, because x cubed can be written as x squared, and that's what the x you are looking for, which is the derivative of this one. So this substitution seems to be working as was expected. So let's see, what do we get? Now we need to find only dx, and dx will be just 2x in the denominator, and in the top we have du. Now you take those information and you substitute them in the integral itself. Now if you substitute them in the integral of itself, x squared plus 1, that is u. So I have u to the power of 7. And instead of dx, I will write 2x, and then here I have du. Now with a little cancellation, I'll cancel x with x cubed, so I will get with x squared. The 2 will go outside, so I will get 1 over 2 integral of x squared u power 7 du. Now there is a catch here. I'm still having x squared. I don't want to see x squared. I need to change x squared into u. Remember, I cannot do anything here. I have to, let me write it as a note so you don't forget it here. You need to change x squared into something with u. Okay, so I have to see what is u and what is x squared. Now if you look at this equation here, I think everything should be clear. I don't want x squared, so I have to write x squared on one side will be u minus 1, because I will just move the 1 to the other side. I will get exactly what I need. So here will be just half. As we said, instead of x squared, I will write it u minus 1, u power 7 du. And finally, it is 1 over 2 integral of u power 8 minus u power 7 du. And now this is a fairly straightforward integral. This will be u power 9 over 9 minus u power 8 over 8 plus c. And the final step, we return back into x, which is x squared plus 1 9 minus x squared plus 1 8 over 8. And that's exactly what we will get here. Okay, we'll continue with the question number 6 in the next video.